Hello and welcome. In this video, we'll explore key differences between two of the most widely used activation functions in neural networks, Sigmoid and Softmax. Both play a key role in classification tasks, but they serve different purposes depending on the problem at hand. Whether you're working on binary classification, multi-class classification, or multi-label tasks, understanding when and why to use each of these functions is crucial. So, let's break down their differences. 1. Purpose. Sigmoid is used for binary classification and multi-label classification, where each output is treated independently. When we say each output is treated independently in the context of the Sigmoid activation function, we mean each neuron, especially in case of multi-label classification, uses Sigmoid to calculate its probability without being influenced by the other output. For example, if you have 4 output neurons in a multi-label classification task, each one applies the Sigmoid function only to its own logit, raw score. This results in 4 separate probability values between 0 and 1. These values are not constrained to sum to 1, so multiple outputs can have high probabilities at the same time. Softmax is used for multi-class classification, where only one class is correct among many. The outputs are dependent on each other because they represent a probability distribution across all classes. This means that if the probability of one class increases, the probabilities of the other classes must decrease to ensure the total sum remains 1. This interdependency is what makes Softmax ideal for multi-class classification, where only one class is considered correct. 2. Input. Sigmoid takes a single scalar value or logit. For example, 0.88. Softmax takes a vector of values or multiple logits. For example, a vector of 0.65, 0.24, 0.11. 3. Output range. Sigmoid outputs values between 0 and 1 for each class independently. For example, in case of multi-label classification, output of each neuron is independent and may not equal to 1. For example, sum of these outputs is not equal to 1. Softmax also outputs values between 0 and 1, but ensures the sum of outputs across all classes is exactly 1, making them true probabilities. For example, the outputs 0.65, 0.24, 0.11 add up to 1. 4. Interdependence. Sigmoid. When used across multiple neurons, each output is independent of others. Multiple outputs can all be high or all be low. Ideal for multi-label tasks. See the example quoted in Output Range. Softmax ensures outputs are interdependent. Increasing the probability for one class decreases it for others. Perfect for mutually exclusive multi-class classification. See the example quoted in Output Range. 5. Gradients. Sigmoid can suffer from vanishing gradient. Softmax, less prone to vanishing gradient issue. Vanishing gradient problem has been explained in detail in videos 13 and 14. This structured comparison helps in choosing the right activation function based on the nature of the classification task. Now let's talk about important applications of Softmax. 1. Multi-class image classification. Imagine teaching a model to recognize photos of cars, birds, or planes. Softmax acts as the final judge, assigning clear probabilities to each class. It's the reason convolutional neural network can confidently say, the given image is car. 2. Natural language processing (NLP). In NLP, Softmax helps machines predict the next word in a sentence or gauge emotions in text. Transformers, like those from Hugging Face, rely on it to make smart, context-aware choices. 3. Object detection. For tasks like spotting pedestrians or traffic signs in real time, models like YOLO version 8 use Softmax to label each detection accurately. 4. Reinforcement learning. Do you know how AI agents choose actions? In reinforcement learning, Softmax turns raw preferences into probabilities, letting robots learn optimal. That wraps up today's video. Please don't forget to subscribe our channel, like the video, share and comment it to stay updated with this series.